What's up everybody, my name is Eric. Welcome to my channel, Eric the Tutor. What's up everybody, my name is Eric. Welcome to my channel, Eric the Tutor. Today we're continuing our discussion on SN2, SN1, E2, and E1 formation of products, okay? So go ahead and pause the video and give this one a try and let me know what you think. Which one's it going to be and what's our major product going to be, all right? So if we jump into this, we can start with, we've done a few examples now, so we can go through this a little bit more quickly, okay? So I see that this is secondary. I see is this good or a poor nucleophile? It's going to be a poor nucleophile. And we know that because of this O is directly bonded to our hydrogen, okay? So we'll only have two available lone pairs. And we see we're in 0 degrees Celsius. That's going to be a little bit different, but we'll talk about that in just a second. All right, so these are ideal conditions for doing an SN1 and E1, okay? SN1 and E1. So let's go through the mechanism to see how exactly this works. Well, the first step in SN1 and E1 formation is to go ahead and give us a carbocation. That's always going to be our first step. Now, if we go ahead and do the SN1 style product, we can actually take our OH and we can react it right here. So what's that going to give us? It's going to give us an O, H, and the rest of this group. Okay, then we have one lone pair and now it's positively charged. So we have a Cl minus floating around. This Cl minus can come grab our hydrogen, break this bond, and push on a lone pair onto that oxygen. That's going to give us okay. Now this is something that's known as a racemic mixture, which means anytime we form that carbocation intermediate right here, we only have 3 groups coming off of this carbon, which means it's sp2 hybridized right now, which means it's planar. It's trigonal planar, okay? So because of that, you can think of it as being flat. Now this group can either attack from the top or it can attack from below. So that's going to give us a mixture of products that will look like this or just like this, okay? So these are the SN1 products, and they are equal, which is known as racemic. We get those at about 50-50 for the SN1. Now, if we go ahead and draw the steps for our E1 formation, here's a positive charge. We can take our nucleophile, and we're going to grab a hydrogen from next door. Now notice, here's our alpha carbon, and here's the beta carbons. So I can grab one from here or from here. When I do that, I will form a double bond here. So I can get a double bond formation there, plus HO, C double bond OH, plus and a Cl minus. Or I could have had it attack from this side and formed a double bond here. So I also could have gotten this. Okay, so this is going to be our E1 products. E1. We'll go into which one would be more favorable in future videos, but for now we can say out of our E2 products that this one is going to be our more stable E1. More stable, and this is our less stable E1. Since we're in 0 degrees Celsius, our major products are going to be the SN1 products. SN1 major, which means our E1 E1 minor products. If we had increased the temperature to, say, 100 degrees Celsius, then we would expect to see the E1 products to be the most stable. They would be the more favorable major products, okay? All right, that's it for this video, guys. Thanks for tuning in. See you next time.